Hey everybody, my name is Laura and I'm going to be talking today about multi-cluster Kubernetes today and tomorrow. I'm coming at you from SIG Multicluster, the special interest group in upstream Kubernetes focused on multi-cluster, and GKE, where I work on managed multi-cluster for GKE clusters. So overall, I'm super into multi-cluster all the time, and so I'm happy to share with you a little bit today about what's going on in this space right now and what is coming down the pipe in the future. So let's start off with just a couple cases of what applications are multi-cluster, and the fact is a ton of them are multi-cluster from the ground up these days. Kind of got a few diagrams here to kind of show off some of this too. That first kind of case where we have some sort of organizational reason why there's more than one cluster going on in your overall platform topology. Maybe you have this blue team that is working on some set of applications, workloads, services. You have this green team, they're working on some set of applications, workloads, services. Another case is if you have a totally different, like special kind of cluster that you want to use for just some workloads, but maybe not all of your workloads. Another situation people get into is that there's some central team that manages some centralized services that all other sort of spoke teams need access to. And another situation, particularly highlighting in GKE, there's a difference between GKE standard clusters and GKE autopilot clusters, and they have sort of different overheads in terms of how much you need to set up, how they're billed for, and sometimes there's some workloads that might work better on one. And then all of this may also be part of a case where any one of these reasons may also be coupled with the fact that you have multiple clusters in multiple regions for high availability, for disaster recovery, in which case they won't be participating as a single cluster. They'll definitely be multiple clusters, but maybe you still want them to connect into the rest of the centralized infrastructure or to each other so that they can actually fail over to each other if you need to. So these are all tons of different cases of why applications are just starting out or very quickly becoming multi-cluster from the beginning for tons of different reasons. So multi-cluster, right? It's a group of clusters working together. And I'll talk a little bit more about what working together really means here. But to get a little bit of lingo out of the way, I do want to mention that this kind of universe down here of all of these different clusters that are working together in whatever way they are working together. Again, we'll talk more about the ways that they might later. But this whole sort of unit will be referred to by one of these two terms. Generally, one of the terms is cluster set and another one is mesh. So cluster set is a word that's widely used in SIG multicluster. It has like a very specific definition for the work that we're doing in SIG multicluster about a set of clusters that have some sort of shared trust amongst each other, and some of the other standards that come out of SIG multicluster kind of fall out from that. Mesh is another term that people use to refer to this idea, and that particularly comes through from all the service mesh technologies that are really focused on service discovery as a layer on top of different Kubernetes clusters or Kubernetes clusters plus other types of endpoints. But people will use both of these to kind of refer to this collection O clusters over here that are working together in some way. So you'll hear cluster set and you'll also hear mesh referring to both of these things. Cluster set being a little bit more abstract, mesh definitely tied very closely to the history of service meshes and service discovery. So living your life in a cluster set, there's kind of these two big things that kind of need to be addressed that were taken for granted, I guess I would say, when you were just a single cluster operating as yourself. So one thing is that clusters need to know who they are compared to other members of the same cluster set, as in they need some sort of name, right? So historically, a single Kubernetes cluster, a single Kube API server doesn't have a name. It's the end of the known universe, so it's not, it doesn't really need to know itself as its own unique object. But once we're getting into a situation where more than one cluster is participating together and they need to identify themselves as themselves, they need to have some sort of naming mechanism for logs, you'll see later we'll use it for MCS DNS, multi-cluster service DNS, for all sorts of different situations where the coordinate of a specific cluster is relevant in relation to everybody else in the cluster set. And then the other thing that they need is some sort of mechanism to share some info among one another. So inside a cluster, one Kube API server, there's a bunch of information in there, right, as Kubernetes objects, that is the basis of all of the knowledge that Kubernetes controllers can use to affect how the cluster schedules work or how different things are deployed. But once we want our clusters that all have different Kube API servers independently to be working together somehow, they need some way to share some information with each other. So a little bit more on that first point, I want to highlight something that has come out of the SIG multi-cluster group about that very problem of clusters needing to know who they are. And there is a solution called the About API, which you can go to katesigs.io/About API and check it out. But basically, the idea of the About API is to be a cluster scoped CRD that stores arbitrary cluster properties, like literally the kind is called cluster property. And they are just composed of a name and a value. That value might have some specific restrictions about how it should look based on what the name of that CR actually is. But overall, the point is to have a single place, a single CRD, where the cluster can discover properties about itself through the Kubernetes API. And so like the cute thing we like to say is that the cluster has like self-awareness for the first time, right? Like they're becoming sentient. But the original force behind this About API was specifically SIG multi-cluster needed something to be able to, again, like track like what's the coordinate of this cluster in like a whole participating cluster set, specifically for the MCS API, which needed a cluster name that could be used in DNS. So we'll touch on that a little bit later, but there's lots of usages for this About API. And again, there's certain properties that the KEP that's backing this API specifically mentions, like this cluster.clusterset.kates.io, which is effectively the ID for the length of time that this cluster is in a cluster set, or a property that has the name clusterset.kates.io, which is the name or some other identifier for the cluster set itself as a whole, that whole universe in the bottom corner. So these are properties that have very specific meanings in this KEP, but any other arbitrary property could be stored in the CRD instead that the cluster needs to know about itself. So moving on a little bit, a question that comes up a lot is who gets to actually be in the cluster set. So depending on the size and scale of your organization, how many clusters you're actually talking about right now, or how many clusters you're talking about in the future, slicing this up, figuring out who gets to be in the cluster set, who needs to be in the cluster set or not, can be quite an exercise. So if we could distill it down to just a couple main like precepts about who gets to be in a cluster set. The clusters that are in that cluster set, their workloads must have a reasonable degree of trust. So coming back to that, what reasonable means, but they need to have some amount of trust with each other. In general, they're of the same environment stage. So like you might have one cluster set for dev, one cluster set for staging, or one cluster set for pre-prod, or maybe you have like several prod cluster sets that maybe are separated out in some other way that's relevant to your application that respects some hard isolation boundaries between them. But generally, they're all the same environment stage that ties a little bit back to that workloads need to have a reasonable degree of trust item. And then lastly, clusters usually are in a cluster set together because their workloads depend on one another, though at minimum, they just need to peacefully coexist, right? So they don't necessarily need to be like hard dependencies on each other, like really need to access like every service in blue cluster from the service in the green cluster. And even if a given cluster doesn't have a service exposed or otherwise need to participate too strongly in any interdependence within other clusters and workloads in this cluster set, as long as they can peacefully coexist, putting it inside the cluster set usually has more advantages, including growth advantages for you in the future than not. But in general, like if it was the most abstract, peeled back things, when you're asking yourself, does this cluster go in my cluster set? These are the kinds of things to consider. So a little bit more on reasonable degree of trust, and I'll have another concrete example later too, but it basically boils down to the workloads need to be okay with a consumer of some workload in some other cluster potentially knowing where that producer lives. So even if it's on a different cluster, knowing something about where it lives, maybe other consuming workloads or other workloads on a given cluster that aren't direct consumers of that kind of know that it exists. So being okay with the fact that you know that this other cluster and these other workloads, these services exposed from that cluster might exist, that's kind of a good sort of like temperature check on whether we have a reasonable degree of trust between these workloads. If we absolutely do not want to know, don't want these workloads to know, don't want anybody in this cluster to know that these producing workloads exist somewhere in the cluster set in some other cluster, then that might not be a reasonable degree of trust anymore. But importantly, they don't necessarily need to know the details of how that producer is deployed. They don't have all the full introspection of the Kubernetes API server in other clusters. They only have a limited amount of information. So whereas the cluster boundary as a hard isolation boundary using these multi-cluster tools and technologies, some of which I'll be covering today, still provides some permeability between those clusters in terms of being able to know enough about the other clusters, Kubernetes API objects in order to do something like service discovery, in order to like hit the service that's being exposed from blue cluster, from green cluster, right? In a way that's, sane and easy to keep track of and feels very Kubernetes-like instead of just like a random external name IP. But even though we have some shared information, it's not everything. It's not like we're wholly able to introspect the Kubernetes API server of a different cluster. So that's where this reasonable thing kind of becomes a nuance and gives you sort of a distinction between everything inside your cluster and what it can know about in the cluster and things that are in separate clusters and how they're only sharing a little bit of information. So notably, this means that the cluster isn't the end of the world, right? The cluster now needs to know its name. It needs to be aware that there's some information flow between it and other clusters of, other types of other workloads. So this actually kind of introduces a new POV of this idea of a person or team, organization, department, maybe not literally a purple meeple with cool sunglasses, but somebody who has administrative privileges over this entire cluster set, over this entire platform of clusters that are working together. So this cluster set admin might have their own sorts of concerns. We'll kind of dig into that in the next slide. But one thing that I really want to highlight and give our purple meeple here the chance to say is stop giving out cluster admin, y'all. So definitely cluster set admins are not going to be loving a world where there's a lot of cluster admins running around within this cluster set because, again, there needs to be some reasonable degree of trust between these workloads. There is going to be some information that is shared between them. So individual clusters going kind of far off from the tolerable acceptance level, I guess, of what that means gets harder and harder to track if wholesale cluster admin privileges are being given out all around the place inside this cluster set. So If you're a cluster set admin today and you've said this, or you're going to be one, you might be saying this in the future. So just like to give our purple meeple a chance to say that to everybody here while we're all collected. But if we think about what are the things that are making the cluster set admin's job hard, besides arbitrary cluster admins doing whatever they want, I kind of organize these into 4 things, and these are like the big 4 problems that multi-cluster kind of needs to solve. So some of these things were actually solved in single cluster Kubernetes, like in the sense that individual nodes working together needed to figure this out in single cluster Kubernetes. But now, again, we're moving into this multi-cluster space. It's a little bit different. So some of these problems need to be solved with that in mind. So kind of comes down to config drift, more clusters, more problems, right? There's potentially like lots of deviations that could happen if you don't have a good way to keep all of your configurations synced between different clusters in a cluster set. Scheduling and workload placement, making the decision of what workload goes on what cluster, who has credentials into a specific cluster and can deploy workloads there is kind of another side of that same story. So this is also a problem that needs to be solved in the multi-cluster world. Storage, multi-cluster storage, and stateful workloads, which is, the basis of what that multi-cluster storage is being used for. The ability to move these around or know where they're located is a really pressing need for people who are hosting their stateful workloads in deployments that are multi-cluster. Even just from like the blue-green upgrades perspective, this is valuable, but in just a cluster set topology where there might be a lot of, there might be a need or interest in migration of stateful workloads across cluster boundaries, figuring out a solution for that is really top of mind for folks. And then the networking part, the service discovery, the actual ability for a workload and service in cluster blue to be accessible and understandable from a workload in cluster green. That is the basis of actually most of the current solutions that provide multi-cluster capability because working together a lot of times means traffic may flow between different services and the Kubernetes services that are exposed on those individual clusters. So the like real one slider version of all of this for config drift, there's a lot of GitOps like solutions out there, some different third-party solutions, some that like belong to different clouds. In general, this is kind of the direction that config drift solutions have been going. For scheduling and workload placement, this is an area of active research, I would say, for SIG multi-cluster. The latest project in this space is something called Work API. I'm not going to talk about it today, but definitely if you're interested in this idea of how do I get the workload, this package O work that may be a deployment, but it may be other Kubernetes API objects, some payload of Kubernetes API objects to one of the clusters that I have based on something more than just like kubectl deploy this manifest to this cluster. Definitely take a look at the work that folks are working on in SIG multi-cluster for Work API. And then for storage and stateful workloads and networking and service discovery, both of these I'm actually going to talk about a little bit longer with the time that I have today. There's some like super fresh, new as of like the last few weeks work going on in the storage and stateful workloads space. So I'm going to take a slide to talk about that. Specifically stateful set slices. There's a KEP related to it, and this idea of a cluster migration KRM object. And then on the networking and service discovery side, this I have a lot of experience with in SIG multi-cluster, but MCS, multi-cluster services, MCG, which is multi-cluster gateways, and then tons of other third-party meshes like Istio are all solutions in this space of being able to express service discovery across multiple clusters, across multiple Kubernetes API servers, not just the service object and the service networking that's available in a single cluster situation. So talking a little bit about one of those service discovery options, the MCS API. I have talked a lot about this at other conferences too, so definitely look up some more vids by me if you want some more details about this. But in general, the idea behind the MCS API, which is sort of the latest flagship project of SIG Multicluster, is to take the service object, so like your regular old service object that you're used to in Kubernetes, and provide another API object, a service export, that declares your intent to make that service accessible across the cluster set, so that it's actually, a service that you're not just publishing within this cluster, which is what the regular Kubernetes service API knows how to do, but actually beyond that, share it throughout the rest of the cluster set. And then it also introduces this other API object called a service import, which is kind of the corollary on the destination clusters of the minimal amount of information that the destination cluster needs to know in order to actually route to the service back in the place where it actually has backends, where it actually has workloads backing it, endpoints backing it. So if we kind of go over here to this YAML section, if we're in a world where we have a service that has a name purple that's in the namespace prod and has other service properties on it, the idea behind a service export is that it's this really minimal API object. It's of kind service export, and you just specify the name and the namespace of the service that you want to export. So it's kind of like a little flag that's saying, hey, in this cluster right here, there's a service called purple in the namespace prod. I want that one to be out in the cluster set, available out in the cluster set. And if we kind of look at what that translates into in the destination clusters, the sort of green outline here, by having made that purple service export over here that, again, just says like, hey, I just want to, say that, like, wave this little flag that the service should be accessible to everybody in the cluster set, then all other clusters in the cluster set will get this service import created that has all the minimal information that they need to know to actually route to that. So they know the IP of how to actually route requests to this service of name purple and prod that will actually route to the backends that are actually in the purple cluster itself. So tons more information in the KEP and some other videos out there from the past, but that's the general gist about the MCS API as a API to describe this desire to publish your Kubernetes services more widely across your cluster set. And I feel like this is a good example to kind of take us back to that remembering the reasonable amount of trust question, where, this purple service is like, I'm the purple service. And then over here, the service import version of it over here is like, yes, I am the purple service, right? So there is this shared information, the actual backends themselves, the service source itself is actually over here, but you have the privilege from this other green cluster in this cluster set to have discovery of the service all the way over here. So this, in the case happy case, this means that if you're a consumer of this purple service, but over in this green service, yay, you can use like regular old Kubernetes DNS to access that service. But the flip side of that is that lots of other workloads inside this green cluster are aware that at least this purple service does exist somewhere in the cluster set. So this is the kind of thing that we mean when we say there needs to be some reasonable amount of trust within the workloads that are in this cluster set, because there is some information sharing that's going on to make it possible for these clusters to work together a little bit more seamlessly, more in a Kubernetes way, without literally being one big mega cluster. So if I kind of put everything I just said into one slide, the big takeaways here for multi-cluster today is that it's used for these very real situations where organizations do have multiple clusters and they do need to work together. And they're sharing less information than a single cluster that has one Kube API server does. Like they have that would have full introspection to everything that's going on in that cluster. but it still leverages some sharing of Kubernetes API data where it's useful. So we just saw an example for the MCS API where we're going to transport the minimal amount of information from the source cluster about that service API object to the destination cluster, so it can still, stitch together in a very Kubernetes feeling way the access to that service, even though it's in a totally different cluster, without like wholesale copying, the whole Kubernetes API server over, right? So as a side effect of all of this, it is assuming a reasonable degree of trust between workloads. We talked a little bit about what that means. And as a result, the cluster boundary itself isn't the end of the world anymore. So this has a number of implications we talked about, including that it introduces this idea of a cluster set admin, some role, persona, department, team that has the privileges and perspective over the entire cluster set to aid in all of the management of those clusters and consideration of all of these factors and kind of those big four: the config drift, the scheduling, the workload placement, the stateful app storage and migrations, and the networking and service discovery. So when should you not use multi-cluster? I already said that I am pretty much super into multi-cluster, so it's a bit difficult for me to even suggest such a thing. But of course, it depends, right? Everything always depends. And your situation may require to not be using multi-cluster. And I think the briefest version of it, especially thinking about all of that was just on the last slide, is that when you can, or particularly when you must, share more Kubernetes API knowledge between workloads than these multi-cluster solutions allow, you're really in a spot where you should not be using multi-cluster, because the cluster boundary still has some strength, right? It's still a piece of isolation, and if you need a lot more introspection into what's going on inside a given cluster's Kubernetes API server, you're not well suited to using these multi-cluster solutions, which kind of keep that information transfer at a minimum. All right, in my last few minutes here, I do want to talk about more multi-cluster on the horizon. So one thing that is an issue, let me direct everybody's attention down here into this little corner. If we have this universe over here, right, our cluster set, this is all fine and dandy. Maybe, everybody's talking to each other, but at some point, some external client is going to want to contact your application, right? I assume that you're not like totally just living within like the bounds of your universe and never letting anybody from the outside in, right? So at some point, whatever the applications hosted in here are, at some point there's some front end, there's some ingress where external clients are going to want to get in and access, parts of this application. So it's no longer so clear cut, like which cluster do I go to, right? So like if I have, my cool company.com/shop or whatever, which of these clusters, if there's a front end deployed on all of them, or if there's a front end deployed on just some of them, or there's a front end deployed on one of them that like certain clients should go to and other clients shouldn't go to, it's a little less clear, and the bigger your multi-cluster deployment is, the more that would be to handle like yourself with DNS. However, the Gateway API, which is a project of SIG Network, which is in beta right now, has some variations which do support multi-cluster gateway classes. So specifically, again, I'm from GKE, right? So there's a GKE implementation of the Gateway API, which does have multi-cluster gateway classes. So you can describe a gateway. There's, in the Gateway API in general, there's these gateway classes that can all have different, implementation-specific properties about them. And then separated from the gateways are these routes. HTTP route is one of the kinds of routes that actually describe, using this gateway, what paths should go where, right? So the more like platform, like network administrator side is making these gateway objects, and then the application developer side persona is making more of these routing objects. And here you'll see that in the GKE case, there are some gateway classes that end in MC, which means multi-cluster, and they're able to load balance across service imports. If you scroll your eyeballs down to here, you'll see that this HTTP route actually describes a bunch of stuff that I skipped, and then that the backend for all of that stuff that I skipped should be a service import of this name. So this is a way that a client coming in, asking for whatever this host name is that I skipped out of here, that the way that this should be routed to across these clusters is, sorry about that, the way that this should be routed to across these clusters is to this service import, that it could go to any service that's exported of that name across, whatever clusters that they're deployed in. So this is an example of using the Gateway API, specifically using the multi-cluster gateway classes that are implemented in the GKE implementation of the Gateway API to manage ingress into a world down here where there might be lots of ingress points, or there may be lots of ingress points where only a subset of them do you need to make a decision from the client side, and then it can kind of, the traffic can be load balanced across them. So all of these variations you can, and more actually, it's like a really great API, you should check it out, are described in the Gateway API. In fact, I want to give some kudos to Rob Scott. There's many people who have worked on the Gateway API, but Rob Scott is one of the main maintainers and has talked to SIG Multicluster about it a lot. And coming up in KubeCon North America, he's going to be giving a talk about it. So if you have more interest in this, definitely check that out. And then the last newness, which is like 2 weeks old or something, I don't know, maybe a little bit longer than that, especially by the time that this actually gets published. But there's some totally new active development work that is very open to comment right now regarding how to handle multi-cluster storage and how to handle stateful sets in particular, which are usually tied to some very specific storage on a specific cluster. How to get them to move, right, to a different cluster if you want them to. So there's this KEP 3335 linked here that's trying to address what it calls a split brain problem. So if there's the stateful set controller on cluster 1 and the stateful set controller on cluster 2, under normal today's circumstances, they don't know anything about each other. They don't know, like, they have no idea that they might be participating in like a migration of the same stateful set between these, two clusters. So they like just don't know what's up with stateful set controller 1 or stateful set controller 2. So like the control plane is totally split into these two brains. But there's some suggestions here specifically for that split brain problem, which then goes on to be valuable for what was a very cool demo to SIG Multicluster, which is linked in here too, to make it possible to transmit at least enough information to one side of the split brain to say you are in charge of this number of replicas starting at this ordinal number, whereas this controller is in charge of this number of replicas starting at this ordinal number. And then you can modify these as things go so that each individual controller is like, oh cool, I'm in charge of like this starting from there, I'll make that thing now. I need to like eventually reconcile with the fact that I'm in charge of now 2 replicas starting at ordinal 1 or whatnot. And that's how we can transmit this information to each controller separately, that you're in charge of app 0, app 1, and then later this controller will be in charge of maybe app 1 and then app 2, and then eventually app 0, app 1, and app 2 will be able to move them over slowly. So those are really brief, representation of the problem. There's some great info in this KEP. And again, I would like to give some kudos to Peter, who is the author behind this KEP and also came to talk to SIG Multicluster about it. And he also has a KubeCon North America talk where you can hear all more about it too as well. So clear that on your schedule for later this year if you're interested in that too. Or click through to this KEP. He's looking for comments right now, so it's a great time to say something about stateful set slices if you're interested in that. All right. Well, thank you so much. That's the whirlwind of what I wanted to tell you about multi-cluster Kubernetes today and tomorrow. There's a lot of cool, exciting work that folks are working on in SIG Multicluster. So if you want to meet them or if you want to hear from me some more, I'm always there as well. We meet bi-weekly on Tuesdays. There's a tiny URL link here to the notes. You can check on the agenda or throw yourself on the agenda at any time, and we would love to talk to all of you. And with that, thank you again, and I will see you in the future.